Welcome back, Juno community, to another episode of Building on Juno Developer Series. I'm thrilled to have with us today James from SubQuery. James, how are you doing, pal?
Thanks for having me, Highlander. It's great to be here. It's great to be finally talking. We've been chasing each other since autumn, wasn't it?
Yeah, yeah, it was a bit of a crazy one over there. It was so many people, and your day just gets away from you. But yeah, we made it. We
It
hooked
always
up and
does.
we're here now. So we'll just have a little bit of context on what we're doing in this developer series. So we are going to get some more content built out for not only the community to see what great tooling's available on the Interchain, but also for developers who are interested in actually making a switching, building on Web3, building on the Interchain specifically, Juno as well, and yeah, just see how we go with it. So, James, appreciate you coming on and spending a bit of time with us today. Tell us about yourself and what SubQuery does, please.
Yeah, thanks. And so my name's James Bailey. I'm the Chief Operating Officer of SubQuery. I've been working on with the SubQuery team for the last few years, and how time has flown in the space. I'm sure everyone here knows how busy we get and how fast time passes. But SubQuery, before I explain what SubQuery does, let me maybe explain about what the problems it solves. So we'll talk about what SubQuery is. We'll talk about how it works with Cosmos and Juno and Interchain, and then we'll give you a live demo as well to kind of run through things, and hopefully everything goes perfectly well. So let me just skip through to the problem that SubQuery kind of solves, and that is query speed. Now, when you're building a complex application on a decentralized protocol like a blockchain like Juno, you need access to large amounts of data. And the key problems with with blockchains is the way that the consensus and stuff's a masterpiece, but the way that it provides access to query that data, it's got a lot to be gained from it. It's not necessarily designed for the fastest query speed. So if you're building a large application that has hundreds of thousands of users around the world, these kind of decentralized apps will need to have another layer here to bring them up to the performance that people expect in Web 2. And I think this is one of the big things that Cosmos and Interchain is kind of going through at the moment, which is the number of new zones coming into the Interchain is still it's a lot every month. But we're starting to see now the applications being built, and these applications are starting to take advantage of what Interchain brings, which is this kind of consistency between all these zones. But these applications are going to need data tools to be able to analyze and
Yeah,
aggregate that data in a fast way to support a large amount of scale, to support an intuitive application, and to support higher performance. And the second problem here is the interchain complexity, right? So because there's so many different Cosmos zones, and anyone building on the interchain is probably thinking about building on one or more zones. You probably want to be able to provide a similar user experience in each of these zones in the interchain. And so when we talk to teams building dApps and interchain, they also had to express this concern for the number of zones that are coming through and the amount of administration effort, the amount of development effort it is to support all of those zones. So these two problems together are kind of one of the key reasons why I built SubQuery, and SubQuery is in itself designed to solve this data problem. SubQuery is a indexer. An indexer is a tool that constantly scans and aggregates data on a blockchain. Let me just, so this slide's um, a bit old. SubQuery is an open source project that allows developers to index, transform, and query data to power the applications. And what that means is it's basically a computer on the side that runs side by side with the blockchain and pulls off the data that you're interested in and provides it to your application in a more powerful, more performant, and more custom API for your dApp. And it works seamlessly across all Cosmos zones, all applications interchain so far that we've found. Specifically, it works in Tendermint, on Cosmosm, and on Ethermint, which are the three main kind of areas that people develop in the interchain. So if you're building a dApp, an application, let's say you're building an application in Juno, This is a kind of understanding of the stack that you might build. The tech stack, you have your Cosmos chain at the bottom there, Juno, which obviously is powered by CosmWasm, or the smart contracts on it are powered by CosmWasm. You might make a query through an RPC interface provider to that to save and retrieve certain amounts of data. So let's say this app is an NFT marketplace. So you query NFTs, or you initiate transactions around those NFTs through an RPC interface. Your UI on the top might be built in React, and that's a visual layer that your users see and access all the times. You might have some off-chain storage through IPFS, for example, some oracles, but the data indexing piece on the left-hand side, that's where SubQuery comes into it, okay? So if we look at this as some example providers out there, SubQuery doesn't save data to the chain. It has a side-by-side process to bring that data out, to aggregate it, to make it in a better format, to make it more efficient to query, to help power and build a better experience for your users in your dApp. That's really all it matters. It's about creating a better user experience to narrow the gap and the divide between the look and feel of Web3 apps and Web2 apps.
That's really good.
So,
Really good stuff, man. A fantastic
yeah,
explanation there. I did realise what SubQuery was doing, but now when you actually show me an image of that, it makes total sense what you're doing. Are you effectively like the module you insert into your application, which then allows SubQuery to query data from the chain back and forth to your application?
that's exactly right. So we'll get into that in the demo in terms
Yeah.
of how you set it up, but it's very straightforward. It's SubQuery is just a custom API for your
Aye.
application. So let's say your application is a unique NFT marketplace. You need a unique API, and a lot of people do confuse SubQuery with other API providers. So there are some providers out there that provide like
Mhm.
NFT APIs or transactions APIs. They do a very similar thing to what SubQuery does, except SubQuery is open source, it's fast, it's flexible. And the flexibility means that that unique application that you are building that is different from your competition, SubQuery can provide that unique set of data back to it. Okay? You don't have to take an off-the-shelf API and provide an off-the-shelf dApp.
Yeah.
You can kind of maximize the competitive advantage of your application.
Fantastic, amazing stuff. So, how is the safety aspect with your like subquery API? Because I know standard APIs can be quite hackable. Is there anything like subquery do in terms of security and stuff like that?
Yeah, so one of the things about SubQuery is very straightforward in terms of it only reads data from the chain.
Ah,
And what that means is that as long as the chain is secure,
yeah,
SubQuery is technically secure. Of course, you can DDoS the SubQuery project, but it's open source, we provide a lot of information about how to run this in an efficient way. We provide a lot of information about how you might run this to minimize the attack
yeah,
vector on it. But the security aspect, is not meant to store any
yeah,
information that is not publicly available on the
yeah. That
chain.
makes sense.
And people ask, why, what's the data privacy aspect of SubQuery? Well, I guess you could argue that, like if the aggregation of certain bits of data on the chain might be private, but anyone can kind of come up with this.
Yeah.
So we're just exposing public information in a better way.
Exactly. The blockchain's public anyway. I mean, what you're doing is you're just filtering out the stuff you need from it. Because it's difficult. I'm a validator. I interact with the chain as well, and it's quite hard to
Mm.
try and gather data from certain aspects of the chain that you need. You know, so it's definitely a field that's needed.
And Highlander, you're a validator. Like how big is like the state, the storage that you require as a validator
Yes.
to run a full node on
Well, that's
Juno? It's
yeah,
terabytes,
it's
right?
huge, and also the fallback from that also it means that people are now having to do like intensive pruning to try and combat that data storage as well. And it was one question I raised in my early days as validating. Like, where's all this data going to live? Like as time goes, as chain grows, it's like where are we storing it all? 10 years down the line, okay, pruning it, but you're losing your data history then effectively.
Yeah, and that's exactly right. That's one of the big challenges we have in Cosmos is archive nodes aren't common in Cosmos. There aren't many of them. And I think that's partly because you validators are doing an excellent public service in terms of running free RPC
Hmm.
endpoints. But you, of course, have to control costs, and it makes sense. SubQuery does have an aspect there. So rather than rely on a centralized RPC provider that has a huge monolithic archive node, one of the few out there, you can use SubQuery to kind of decentralize that information. So you can pull out of that archive the information that you're worried about, that you care about, and have it side by side. So there's an element there of data security in terms of security against someone losing it. There's an element there that you're not relying on this archive. So if your user retrieves information about a transaction made 5 years ago, I'm talking about in the future here, right? But 5 years ago, and most nodes have pruned that by that point. Your SubQuery project could have that directly in the database. And with SubQuery, right, it's about indexing. So indexing isn't the process of copying everything. And a lot of people have this misconception that, can you tell me instantly about this little bit of information that happened 2 or 3 years ago? And I can kind of tell you that, but the way it works, and we'll get into this, is that it pulls information off, and you tell it explicitly what you want to pull off. So rather than have terabytes and terabytes of storage needed to run a SubQuery project, if you're only interested in transactions that relate to your smart contract, you can index just that information, and it makes it much more performant. So rather than think of it this way, Highlander, if I were to give you a piece of paper and say, can you tell me how many times this character appears on this bit of paper? You could probably tell me that in like 30 seconds. If I gave you a book and asked you to give me the same thing, it would probably take you a few weeks to go through that book and count them out. And computers are fast, right? But if they have to scan the entire blockchain, all 9.6 million blocks now on Juno, it takes a long time to scan that information. So asking simple questions of a blockchain for an RPC, like give me the last 10 transactions that this account has made. The only way you can really do that is by scanning each block sequentially back in time until you find the next 10.
Yeah, it's a lot going on, isn't it, when you think about it?
And that's why indexing is a critical tool for dApp developers. And that's why we're really excited about Cosmos, because Cosmos, as I said, is going for that inflection point of you've built these amazing zones. The Interchain's got these great zones now, zones where you can do, which are great DEXs, zones that are great to build your smart contracts and deploy your apps on. Zones that serve as excellent bridges to other ecosystems. But now I think the next phase of the Interchain's growth will be on the dApp side.
Definitely.
To take advantage of these foundations that you guys have
built. But built the building blocks now. It is the Lego method. It's looking great. Now it's the applications layers needing to be brought into fruition. Shall we get into a little demo then, how this stuff is all set up for any of the devs out there that are watching the show today?
Yeah. Let's run into it. So I'm going to do this live, and we'll see if it goes well. As always, things always go wrong. So SubQuery is open source. Essentially, how it works is a TypeScript project. I've installed a CLI to my terminal using npm, and I can now run it like so. And I'm just going to init a new project. So I'm going to do it in Cosmos. And I'm going to do a Juno project. You can see here we support many different ecosystems. And I'll kind of show an image of all the ecosystems we support, but we've kind of been working our way through Cosmos to Interchain. We believe, as I said before, we support any Interchain zone, but we've tested and built example projects for these ones. So Juno one, very simple. It's now pulling a templated Juno project for me and saving that should be to my desktop, taking its time. Yeah, here we are. So I'm just going to skip through this here because it's not as useful, and I'm going to CD into my folder that's on the right hand side here, and while I wait, I'm just going to install it in the background. It's because I named it with a space, so my project manifest, has got a space in it. It should not have a space. I'm just going to install Yarn in the background. And while that runs in the background, we'll have a look at this project. So I have now initialized a brand new project on my local machine. This is everything I need to do. And I'm going to walk through this page by page. There's a great README here that kind of explains what I will, that I'll show you. And if you look at it, you can kind of follow this README. But I'm going to go through this with you live. Now, there are 3 files I edit when I'm building a SubQuery project. and it's very straightforward. 3 files, all you need to change in order to build your own custom API for your Juno project. The first file is the GraphQL schema. Now, this is the shape of my data. Essentially, the way SubQuery works is there's 3 services. There's an indexer, there's a Postgres database, and there's a GraphQL query service. GraphQL is a query language that developers might use to query a server. Now, the GraphQL schema defines both the query language, but also the database schema. So I'm defining here in this example project, it's a very straightforward Juno project, 2 tables, an execute events table and a messages table. And these tables here have these columns. Very straightforward. Okay, so all I'm doing here is indexing execution events and various messages from the Juno chain. Okay. You define your types, and these basically become 2 tables with 4 columns or 5 columns in this case. So that's my GraphQL schema. There can be relationships in here. In this example, I don't have any relationships, but one-to-many relationships. You can put indexes to speed up performance. There's a bunch of documentation, which I'll just jump over to here to show you Academy, because we've got a lot of stuff here. There's some interesting types here that are a bit unusual, but it's very like big int. You have integers, big ints. Integers, big ints just mean
bytes.
More than I think nine significant figures or something.
It's huge.
So this is the GraphQL schema file. This is the first file I usually touch, and I usually edit it. Essentially, what happens here is I can then I'll bring up my terminal here. So we define this, and we can define types. And I just write. I'll just do some types now in the background. Now, while I'm doing that in the background, I'm going to look at the manifest. So the manifest is the next most important file. This is the what and the when of what I'm indexing. So I'm indexing from here, from Juno 1. I will bring back a endpoint that I've lost here, actually. Don't know why I dropped the endpoint. Let's pick up the Juno endpoint.
Would you need an RPC endpoint?
Yeah, do you have an RPC that's publicly available?
Yeah, we've got one.
Excellent.
A little Chain Tools plug live on the show. Happy days.
Yeah, there we are. All right, so I'm going to come back to this file. So, okay, so now we've got the second file. This is a project manifest. This is the what and the when am I indexing. There's a bit of boilerplate at the top, but the main thing down here is this network section. So I'm indexing from Juno. I'm indexing, now SubQuery doesn't require you to run your own archive node. You can see here I'm using a Chain Tools one that you provided. Thanks, Highlander.
Welcome.
Any public RPC endpoint will work. If you have your own one, that's fine. If you want to find one of the ones online in public, it's fine. It just has to have the history of the chain. So this is, again, coming back to a conversation about archives. If you want to index historical information, you've got to have an RPC that has that history. So that's one of the challenges in Cosmos. But if you've just deployed a new smart contract, it shouldn't be an issue. The dictionary is a tool that we've built to speed up development. That's a standard thing, and don't have to change that. And then if you have built for different Cosmos chains, we sometimes have to import some protobufs. These are for any custom type overrides that chain has imported. In Juno's case, we don't have to. But you will see for other examples that we've provided, there might be some custom types that have been imported. Now, the magic happens down here in the data sources. Essentially, imagine SubQuery as a scanner. It just scans the entire history from the chain, all the way from the start block, all the way to the current latest block. And it keeps looking at each new block as it is finalized and submitted to the chain. Now, there are 4 types, of handlers in Cosmos. There's a block handler, there's a transactions handler, an event handler, and a message handler. Now, these represents trigger points. So imagine you build a smart contract, and let's say it's an NFT marketplace, and anytime an NFT is minted, you emit an event on Juno. This is kind of how you index. So you basically look at these events, you filter certain things. So in this case, I'm doing a very basic example here where I'm looking for any contract execution messages. But you might, for example, have a emit event called mint, and it might be from your custom type here, and you can have a specific contract you have, right? So you define, there's various filters we have here, and we're very particular about providing a lot of different filters. but you're basically defining trigger points for whenever something happens on chain. I want to do something. I want to take the information. I want to save it. That's fundamentally how SubQuery works.
Great, that really good stuff. That James.
So in this case, we have two. This is a very straightforward Juno project. I'll show you a bit more complicated next. But we have a handle event and a handle message. So whenever any of these two get triggered by any event on chain, we run something in our mapping files. Now, a mapping file is written in TypeScript. It's very straightforward. Essentially, we have two functions that were defined. Whenever they receive a message that matches the filter criteria I've defined, we do something. Now, in this example, it's very straightforward. We're just creating. So remember from our schema file here, we've got these
Yeah,
types. We're just creating and saving data under these types.
yeah,
This
got
is
it.
very simple, very basic example. But you can do whatever you want in here. It's TypeScript. So you can import libraries if you want. You can read information out of the store, out of the database. You can update
Yeah,
information. You can delete information. You can make an RPC call to on-chain state to get additional information. You could make a HTTP request to CoinGecko to get the current USD price at this point in time. It's very flexible.
right.
And essentially, all you're just doing this. If you're a data scientist, you'll know there's something called ETL: extract, transform, and load. This is the transformation and the loading of data into your data set.
Wow.
So I've defined something really simple here. I'm going to just quickly jump over to a more complicated example, Highlander.
Absolutely, yeah.
This
Of
one
course.
is
It's
a one
great.
that we built when we first joined Juno. This one we built because we actually got a funding from Juno from
Yeah,
your
I was going to say that. Like, but we can ask that towards the end. I was just going to ask you how you stumbled across. Um,
yeah. So what we came across in Juno from the Terra Developer Fund, and we basically had support for Terra a week before their demise. Like, it was a horrible timing, you
yeah,
can
yeah,
imagine. But this example project we built just indexes every single vote made on every single proposal. And it's another very simple example. There's only one type of entity, a vote.
yeah.
And I probably should have put two, a proposal and votes. The manifest is indexing any message from the contract, the specific smart contract that is under the vote call. So it's very simple contract, this developer fund. And there's a particular contract called vote. And whenever someone votes, we handle that vote. And you can see what I'm doing here. I'm just saving a new vote record. Okay, so these are very simple examples, but they give you an understanding of like how you would index information
That's great.
in the space. Now, I've got this project here. To run it, I'm just going to write yarn dev. What it does is it builds it. It does code gen, so it generates the types, which I've already done here. This is why everything's typed out nicely. It builds a project. We use Docker, so by default it will spin up a Docker
Mm-hmm.
container, and within a Docker container there are three services. There's an indexer, a Postgres database, and a query service. And you can see it's just
Yes.
starting up, so it's initializing your Postgres database. It's deploying the schema that I've defined here in this graph schema, and all goes well. In about 30 seconds, it will start indexing. And it's connected to your RPC endpoint now. It's just checking everything's setting up and working. It's just throwing errors that my database does not have RPC, SSL, but now it is indexing. So it's screaming through. Hopefully not DDoSing your endpoint right now. It's got 4 threads
Don't
running
worry.
simultaneously indexing blocks. And basically, if I open up localhost 3000, I believe it's localhost 3000. Just starting up the GraphQL endpoint, sorry.
Yep.
Here we are. I can make a request. And this is in GraphQL.
Okay.
So for example, I've got an example here that I'll just copy over. And GraphQL is very straightforward. And I have data.
Wow.
So this is of all the execute events happening. Juno. I can order that by, block height descending. I can filter it to all events, filter where the contract address
Yeah, brilliant.
is equal to this particular address.
I mean, that's
That's every
incredible.
action done. I don't know, like contract.
Yeah,
But
I love it.
this is what you need when you're building applications. So this is how easy it is. And so within 15 minutes, I've basically built a custom API.
Yeah.
Now it's running in Docker. We provide a lot of information about how to run it. So you can run it locally in your own infrastructure. It's open source. So we provide a lot of information about how to do high performance, how to prevent DDoS. We also provide a free managed service. So if you want and you don't want to run production infrastructure, which you'll know this, Highlander, like running production services is a pain in the ass, and I wouldn't
Yeah.
recommend it to most people. I think it's probably a reason that I'm prematurely going grey, certainly around the back here. But we provide a pause this because it's slowing my internet down. We provide a free managed service where you can run it. And we are also building a decentralized network. So this is the things that we're building with SubQuery. Let me just remind you what we're doing here, what we're trying to aim here. We're trying to build, when we have built an incredibly fast indexer. It's extremely flexible. It works on Cosmosm, on the core Tendermint stuff. It's open source. It's open to run by yourself. We accept people contributing to our code base all the time. We love hearing feedback. And it's universal. And when I say universal, it works across any Cosmos zone, any zone of Interchain, but it also works so all these different interchain zones, but also we are expanding to all of these different other chains. So outside of Cosmos, EVM chain. So you can run it locally. I'll talk about other ways you can run this, but basically what we're seeing the three different parts. We're seeing the GraphQL schema, the project manifest, and the mapping files. The main thing that we think about when we're designing SubQuery is that it's fast. It's faster than other players out there. It indexes really quickly, and we spend a lot of time and effort focusing on optimizing that indexing performance because it's the main concern by our customers. It's also very flexible in terms of you can index whatever you want, whether it's on Cosmosm or Ethermint. You can build your own custom index if you're in custom smart contract. It's open source. We welcome contributions. You can run it yourself. And of course, it's universal. So we're universal in the way that it runs on all these different Cosmos zones, but also universal in a way that it works across all of these different layer ones. So outside of Cosmos, if you're building on either EVM chains, on Polkadot or Near or Algorand, and many more coming soon, will support you. So you can run it locally yourself, as I said. We do provide a managed service. We know that customers don't want to run production infrastructure themselves. It's a pain in the ass. It keeps people up at night. And so we provide a managed service where you can deploy your project to, and we'll run it in our production infrastructure for you, and just give you that GraphQL endpoint, so you can sleep easy at night, not having to wake up to 2 a.m. alarms.
Fantastic.
There's also, we're building a decentralized network. So we do know that in that tech stack that I showed you before, one of the few things that are centralized are the RPC providers. Although there's enough RPC providers that you don't have risk there, and RPC providers, I promise you, don't have any incentive to do anything wrong. But there are the data indexes. It is generally one or two components, right? And so that server, when it does go down, can adversely impact your application. So we're building a decentralized network, and the goal there is that you can write your project and you can give it up to the network, and multiple indexes around the world can index that, just like validators validate a network. And you can decentralize the data for your application, and your application can query any of those indexes in a trustless, permissionless way. And we're building that process. So that's launching very soon. We've got a pre-mainnet that's live, and we're moving to our network very soon. We just need to do a kind of a public sale for a token and get all that started. In terms of getting in touch with me, here's my details. You can reach out if you have any questions. If you want a demo or do you want to talk about something you want to build, add me on Telegram or send me a message. I'd love to hear what you're planning to build. Awesome. I'd love to hear what you'd like to or give you.
That's fantastic, James. A great demonstration, a great insight of the project as well. I'm going to start implementing some of it and try and build some stuff out and have a little throw around with it. Looks exciting. Maybe part of the developer series we have Comply on the episode just before yourself, and we're building out a little personal project of mine called DAL Records, and it's going to be a record label ran on blockchain, ran on Juno. And what we're going to be doing is simply building out, I suppose it will be an NFT marketplace as well. So we want to kind of try and implement some of the SubQuery tooling behind that and index some of the events that are happening. Would it be something you could come in and advise us on in another episode down the line, maybe?
Absolutely. I imagine you would pay
Yeah, I
royalties
think
per
we're going to,
listen or per play, and so
yeah,
your indexer will want to track every time an
this
NFT is
is it.
played or
It's
anytime it's
huge
accessed,
because,
right?
like, I'm from the music industry myself, and one big problem we found on the up and coming scene, right, is bands are really struggling at the moment, and yeah, they can get funds from like playing live shows, and yeah, you get some money on the door, but what about if we can get tickets as NFTs? If we can do releases as audio NFTs, and then each fan who's turned up at that gig walks through the door and scans that NFT. It's registered on the blockchain. Yes, that person was there. This is like seems to be quite a lot of indexing needing done for that specific industry alone. So it's something I'd really like to go down an avenue with you on and see how you would structure that. That'd be amazing.
Yeah. We worked with many different NFT marketplaces, and even just the showing of all the records of all the different collections that you have, that requires indexing. And when we go to customers, especially on chains like the Interchain, often when we ask them, like, what are you using today? How are you indexing your data? They've built their own indexer. They've gone through and built their own thing, and it's a classic. Like, why
Yeah,
build the
exactly.
wheel
It's
again from
something I've
scratch?
flagged quite a lot of times, and developers have mentioned it to me. Is like we need to stop trying rebuilding the wheel again. It's like right, we've got all this infrastructure now. Let's start being more interoperable. Like the whole point of Cosmos was, and I think a bear market kind of gets everyone kind of competitive a wee bit more, don't they? They don't want anybody to get market edge on them, and I think in a bull run that don't really matter
Mm.
because everyone's kind of like got that security of yeah we're okay, we're secure, and there's liquidity in all the chains. But at the moment you start to see the real daggers coming out, it's
Yeah, but it's
yeah.
short-term thinking, right?
Thank you for your time, James, and I know you're a busy man and I got to get off myself, but really appreciate you coming on the show. And if there's anything else you'd like to add in, please do. But just want to thank the community for always tuning in, and yeah, we'll be back with another episode soon. Thanks a lot, James, mate. Okay,
Thanks
come,
for
I'll
having me
see
on,
you all
Anna.
next time. The
Cheers,
next
man.
episode of Building on Juno. Take care, everybody.